In our Intro to 3D Modeling and Design class, students learn the fundamentals of 3D modeling by using Tinkercad, a free online computer-aided design, or CAD, software. It is owned by Autodesk, who develops software used by many architects and engineers for projects such as the One World Trade Center and Tesla electric cars. Tinkercad is a beginner-friendly software that introduces students to designing and manipulating three-dimensional objects. Once they are comfortable with using Tinkercad, they can move on to more complex and more powerful CAD software, such as Fusion 360. Students get to design and customize their own keychain, dice, Minecraft avatar, and more. Then the students get to make them with 3D printers. This is done through Kira, a software that converts the 3D designs to printable objects. The students learn to make the proper adjustments to make sure their 3D creations are printable. They also get to explore and print designs by other 3D creators. Now I will show you what a sample 3D project looks like. So the sample project will be a personalized keychain. For this example, I'll use our company's name, Immerse. So I selected the letter I, and now I'm going to look and click and drag in the letter M. And since there's only one M, I'm going to make a duplicate and then drag it to the right. Now I'm going to drag in the number 3. Since 3 is not on the template, I need to find it within the shape section. And the interesting thing about why we went and used a 3 in our name is because another company already purchased the domain name for Immerse with the correct spelling. So being a tech company that we are, we use the 3 instead of E. Now I am adjusting the letters and number to make sure they are lined up properly on the keychain. And one of the neat tools that Tinkercad offers is an alignment tool. So I went ahead and aligned it to the top. Now it looks nice and straight, so I can move on. So I have dragged in the S, the E, and you notice that the keychain surface is running out of room, so I went ahead and expanded it some more. Next, I will need to create a period in our name. This is done by dragging in a cylinder and resizing it so it looks like a period. So the reason why we have a period in our name is because it is also our domain name. Instead of going with immerse.com, we went with immerse.in because we feel the slogan, immerse in science, immerse in technology, immerse in virtual reality, and so forth, describes what we do as a company. Once all the letters have been arranged in the keychain, I want to group them into one object. We prep the keychain in Kira. It is a program that slices 3D objects, such as the keychain, into layers, which is how the 3D printers create three-dimensional objects. I need to resize the keychain so it fits on the printer's platform. Since the platform is in the shape of a square, I will have more room to print if I arrange it diagonally. I notice that the keychain is a little thin, so I want to make it sturdier by increasing its thickness. I can now slice the keychain and preview what the print job will look like. I can adjust the layers and the progress to see how the keychain will be made. So it looks like the keychain will print well, and it will be done in about 1 hour and 38 minutes. In our Intro to Robots and Drone class, students will control, tinker, and program a physical robot and mini-drone. They will tackle challenges designed to develop their creativity and critical thinking skills. Students get to work with Edison, a robot that has multiple programming languages that meet the different skill levels of the students. At the most basic level, Edison can scan barcodes that activate preset programs within the robot, the perfect screen-free way for any student to experience the power of coding. EdBlocks is designed for students that are more familiar with tablets. It is a fully graphical programming language which uses simple drag-and-drop blocks, making it ideal for introducing beginners to programming. EdScratch is designed for students that are more familiar with computers. It is also a drag-and-drop programming interface with powerful functionality and versatility. It is based on Scratch, a diverse and accessible platform for computer science education. At the highest level, EdPy is a text-based programming language that teaches students real-world coding. It is based on Python, a language used by big internet companies like Facebook and YouTube. In addition, students will also get to work with Tello, a programmable mini-drone that supports Scratch and Python. The same coding language is used by Edison. Students get to apply what they learn from Edison to Tello, extending their coding skills and tackle exciting challenges unique to aerial drones. In our Intro to Electronic Design and Invention class, students will get to invent electronic devices and tools that stimulate curiosity and creativity. The pieces, called bits, are magnetic and snap together to provide a simple and intuitive experience for the students. They are also color-coded by function and are assembled in a logical order. All the bits can be recombined and reconfigured to create brand new inventions. Now, I will show you a sample of what the students can make. In our Intro to Engineering Concepts and Design class, students learn concepts of civil engineering through Minecraft challenges such as designing a launch pad that automatically loads fuel into a rocket. Students learn to use different engines and materials that are appropriate for the task required. Students are introduced to the different engines that power the machinery in the game, such as Stirling and combustion engines. Students will also get to craft the different pipes that transport blocks, liquids, and energy between different locations. Lastly, students get to craft machines that can mine large areas and make copies of buildings and structures. During this time, students will learn about manufacturing in America, in addition to the infrastructure that delivers power and energy to factories and homes across the nation. Now I will show you what a quarry looks like in Minecraft. First, we need to find a source of oil and a source of water that will be used to power and cool the engines that will be running the quarry. Next, I will place a pump over the oil and another pump over the water that will extract the fluids into the engines. I went ahead and pre-mark areas for the quarry to mine in, otherwise it will default to a small area. I will need to use landmarks to establish the corners of the mining area. I will only need to use 3 landmarks. The the query will automatically establish the fourth corner. Then I will place a query behind a landmark, and a construction zone will appear. Next, I will place a chest on top of the query so the blocks it mines will be stored there instead of being thrown all over the ground. Now I will set up an area next to the query that will generate power from 2 engines and create a connection that will transfer the power to the mining device. Next, I will use pipes to route oil from the pump to the 2 engines. I will repeat this process with the water. Once the pipes are properly connected, I will then turn on the 2 pumps to extract the fluids to the 2 engines. Once there is enough oil and water in the engines, I can then turn them on to generate power to the quarry. And here's when it gets exciting for the students who are doing this. The quarry springs to life, and the first thing it does is to clear the surface of grass and flowers. Then it will create a frame that allows the drill to move around in the mining area. So this is a really neat project that demonstrates engineering principles in Minecraft through building a quarry. In our Intro to Forestry and Agriculture class, students will get to plant and grow trees, fruits, vegetables, and more. In addition, students get to collect and breed bees. In this class, students are able to virtually explore the industry and processes that make the Central Valley the breadbasket of the world. Students get to set up farm machines that automate planting and harvesting. Students get to apply what they have learned in the Engineering Concepts and Design class to design and manage how the produce are transported and stored. During this time, students learn about the processes and scale of modern agriculture in the United States. In addition, students learn about the importance of bees in agriculture as pollinators and the current challenges beekeepers encounter. Now I will give you a closer look of what a farm machine looks like in Minecraft. The farm machine is made of multiple components. The top block with a pipe connected to it is a valve that distributes water to the crops. It works with pipes and machines for the engineering class. The other main components of the machines are located underneath. This component is where you set up the machine and load in dirt and seeds. It is currently set up to grow vegetables. I will go ahead and put some broccoli seeds in there. Let's head back out and see the machine in action. Once the broccoli is fully grown, the machine will automatically harvest it and plant another seed. It is then routed into this chest for storage. In our Intro to Biology class, students will learn about the diverse animal life through Minecraft. Students will get to interact with elephants, foxes, snakes, and more. Students would get to build their own zoo and underwater observatory to show off their animal collection. Students get to encounter animals from different biomes. Along the way, students learn how to tame and breed the animals. During this time, students learn about the real animals' behaviors and living environments, from the deep oceans of the Pacific to the dry and arid deserts of Africa. Now I will show you a zoo built by students.